I'm Anil Kumar, sharing with you some word problems to find domain and range of functions. In the beginning of this semester, I got a lot of requests on this topic, and I hope this will help you to understand this subject better. So we have question number 2 here, which is a 450 meter is used to enclose a rectangular area with a partition as shown in the figure. Well, I forgot to make a figure. Let me make one here now. So, okay, so we have this rectangular area, and let's say this is the partition. Okay, now as shown in the figure, part A is write area of the rectangle as a function of width. So we'll assume this to be the width, right, and that is the length, right? So we have this is also width, this is also width, and this total thing is length. Is it okay? Length is from here to there. So part A is write area of rectangle as function of width. Part B is determine dimensions that give maximum area. Okay, now you can also, let me add here, write domain and range for the function area. Is that okay? So we'll do that part. Okay, now when we say write area of rectangle as a function of width, normally if I write area of a rectangle, so as you have seen, what we have done here is we have assumed L to be the length of the rectangle and W is the width, right? So we've defined our variables. So we say length is L and width is W. Is it okay? And both are in meters, right? So all the units are in meters. Okay. Now area will be length times width. Is it okay? Length times width. Now this has two variables, length and width. We want area of this rectangle as a function of width. That means we don't want L in our equation. We want only W. How do we get that? That's the main issue here. So to get that, we use the first statement, which is a 450 meters used to enclose a rectangular area with a partition as shown. So that becomes the length of the all this fencing, whatever it is, partition, so which is 450 in length. So what we can do here is we can write 450 is equals to 2L, right, plus 3W. Since we need to replace L with W, I will isolate L. So we have 450 minus 3W equals to 2L, right? And then we'll divide by 2. So we have 450 divided by 2 minus 3 over 2L. That is the length. And this, we can call this as our equation number 2. This being equation number 1. And now we'll substitute. Instead of L, we'll write this, correct? So I could write 225 for this, okay? Minus let's do decimals or what fractions, I'm not sure. Okay, for the time being, let me write 3 over 2 here. Width equals to it. Okay, so area now we get as equals to all this, which is 225 minus 3 over 2 W, correct? And that is the length part. Is it okay? Times width. Is it okay? Times width. Now as you can see, everything is in W. So we can write this as area as a function of width. Do you see that? So that becomes the expression for area, rather a function, area in terms of width W. Correct? So that is how you can get the area function in one variable, which in our case is width. Part B is determine dimensions that gives maximum area. Now how to maximize this area? That's part B. Let us also talk about domain and range. I actually forgot to write about it. So let's also talk about domain and range, right? Now, as far as domain is concerned, width has to be positive, right? It cannot be negative, correct? So that is kind of important. Therefore, this W is positive, but this part should also be positive. That means 225 minus 3 over 2W should be greater than 0. Is it okay? Or 225 should be greater than 3 over 2W, or 2 over 3 times 225 should be greater than W, or W is less than this quantity, right? So let's calculate this quantity. So it is 2 times 225 divided by 3, which is equals to 150, right? So we can say 150 is greater than W, right? That means, and this width W should be greater than 0, right? So as far as the domain is concerned, we can write domain as, let me write domain, which is in terms of W, will be, you can use different notations, right? So here we say W belongs to real numbers, so that W is from 0, we say greater than, and less than, it could be less than 150, is okay? Now I'm not taking equal to, because equal to will make it 0, so that could be a possibility, but we avoid taking this as 0 width, right? We have to form a rectangle which we say has some dimensions of length and width. Is it okay? So okay, so that's what we'll have, and we'll close this bracket. Yes, okay. Fine. So we talk about domain. As far as range is concerned, once we find the maximum area, we'll know what range is, because it's from 0 to that place. Is it okay? Right. Now, how do you find maximum when you are given this kind of quadratic equation? You could find two zeros and average them out, and that will give you the width, which will give you maximum area. Perfect. So you can do this, or you can do completing the squares, whatever is good for you. But I'll use zeros here. So from here we can write down zeros are at W equals to 0, and the other one is at 150, right? The other 0 is at 150, when this is 0. Perfect. So for maximum, W will be equals to average of 2, right? 0 plus 150 divided by 2, which is 75, right? So this is the average value. For maximum area, the width will be right in the center. Perfect. Okay. So the area we'll calculate now for W of 75. So what we get here is 225 minus 3 over 2 times 75 times 75. Is it okay? So that gives us the, we'll write here, the area. So let's do this. It is within brackets 225 minus, we'll do 3 times 75 divided by 2, bracket close, times 75 equal to, so we get area 8437. You can do your calculations. Sometimes my calculations can be wrong. Anyway, and the units will be meter square. Let's write down meter square for the units. With this, we can write the range also. So we say range, which is, as far as the area is concerned, is, let me use different notation, is from 0 to 8437.5. Is it okay? So that is the maximum area. Now there could be a debate whether I should include 0 or not. Most of the time we don't include 0, most of the time. Okay, so that is what it is. But in case of what we can do in general is that because that 0, when it is a straight line, it is not a rectangle. So that's the concept. Is it okay? But I think what you should do is check with your teacher. Safe, right? This is very confusing when you have a multiple choice question. So you may or may not include. So check with your teacher. Is that okay? So I really don't know what is correct for you, whether you include or you don't include. Fine. So we have added a part to this, that is domain range, which is our major topic. But let's get back and understand. The idea in word problems is try to make a sketch, define variables, write equations as we did. Isolate a variable in terms of the other, write it, and then find equation in one variable, and that will help you to get to the result. I'm Anil Kumar, and I hope that helps. You can always share and subscribe to my videos. Feel free to post questions, right? Thank you, and all the best.